Hello students, in our last class we have seen the preparation of hydrogens from water, cold water, steam, and then we have seen the preparation of hydrogen from acids and then from alkalis. Okay, now today we are going to see the laboratory preparation of hydrogen. That means in lab how hydrogen gas is prepared. So for this, the first reactants or the materials required is we need to have granulated zinc and hydrochloric acid, or you can take sulfuric acid. These are the two main reactants that is needed for the laboratory preparation of hydrogen. Now, what is the procedure involved over here? What is the procedure? That means how we'll carry out this process. For this, we need to make an arrangement of this. In this diagram, if you see, this is a round bottom flask. You need to take a round bottom flask, and in this round bottom flask, at the bottom, we'll put some zinc granules. Okay, and this round bottom flask is closed with a cork, rubber cork, we can say, with two holes. In one holes, there will be a thistle funnel. This we call it a thistle funnel, which is longer, and the other one, this one is the this in the second cork hole we have got the delivery tube, okay, which is kept in a trough, and in this water will be there and the gas jar will be in inverted position. Now how we'll carry out the process? So what you need, this is an arrangement. So you have taken a zinc granules. So from thistle funnel, slowly you'll add either dilute sulfuric acid or dilute hydrochloric acid. So when you add to this, what will happen? The sulfuric acid comes in contact with the zinc granules and the reaction will take place in this way. Say for example, if you take HCl, then zinc reacts with HCl to give you zinc chloride plus hydrogen gas. That means hydrogen gas. Or instead of HCl, you can also use sulfuric acid. So that will form zinc sulfate plus hydrogen. So in this reaction, hydrogen gas will be produced in this round bottom flask. So that hydrogen gas that is produced will be passed through this delivery tube and it will be inserted in a trough where the gas jar is present in an inverted position kept in water. And what will happen, the hydrogen gas will start collecting over here by the downward displacement of water. Okay, so this is the whole process. That means how hydrogen gas is prepared in lab. Now over here you'll observe that reaction will gradually start in the form of effervescence. You can see the hydrogen gas bubbles coming out of this, and it will be collected over the water. Now over here, as I said, hydrogen is collected by the downward displacement of water. The reason is that one thing is that it is virtually insoluble in water. Hydrogen gas is insoluble in water, and number two, it forms an explosive mixture with air and therefore cannot be collected by downward displacement of air even though it is lighter than air. So we cannot collect it by the downward displacement of air because it is highly explosive in nature. So these are the reason why it is collected by the downward displacement of water. Now the hydrogen gas that is produced contain impurities like hydrogen sulfide, sulfur dioxide, oxides of nitrogen, phosphine, arsen, carbon dioxide and water vapor. So this will be present as impurities in the hydrogen. That means we need to remove these impurities in order to get a pure hydrogen. So if you want to remove arsen and phosphine, then it can be removed by this method. Say for example, it can be removed by this method. In this, to remove arsen and phosphine, it will be treated with a silver nitrate solution. Okay, so when it treated with silver nitrate solution, then the arsen as well as phosphine can be removed. Similarly, if you want to remove hydrogen sulfide, you need to treat it with lead nitrate solution. And for removal of sulfur dioxide, carbon dioxide and oxides of nitrogen, you need to treat with caustic potash solution, that is potassium hydroxide. So in this way we can just remove the hydrogen. Now the precautions that you need to take during the preparation of hydrogen is the apparatus that you are using should be airtight. That means there should be no leakage, because hydrogen gas is highly explosive in nature. So if there is a flame outside the jar, and if the hydrogen gas is leaked, it will catches fire. So in order to avoid such accidents, some few precautions you need to take.